Hey everyone, this is Vedant and Niti. We will be host and co-host for this session. I welcome you all to this session, which is going to be about putting chaos into continuous delivery and how you can actually increase resilience of your application. So let's welcome a speaker for this presentation, Jürgen. He is with us now, and I will just give you a brief introduction about him. So Jürgen is an technology strategist at Dynatrace, and he's a core contributor to the Kepen open source project and responsible for the strategy and integration of self-healing technologies and tools into the Kepen framework. So before moving forward, let me just tell you, in case you have any questions during presentations, you can always reach out to us in the session feed as well as Q&A. And if you want to interact with the speaker, you can always raise your hand and we will invite you onto the stage. You can interact with the speaker and directly ask your questions. And post presentation, if you have any question, you can be taken to the Slack channels. So I hope you enjoy this session and try to take as much as possible knowledge. And yeah, over to you, Jürgen.
Thank you very much. Let me start with screen sharing because I need a couple of slides for my presentation. Hopefully it's already sharing and I think it's all good. So let's get started here. Welcome also to Chaos Carnival. My name is Jürgen Etzlstorfer. I am from Austria, in the city of Linz. And today I want to talk a little bit about why you want to put chaos into continuous delivery and how you can do this. And maybe you've seen already the keynote today from Uma. He was also talking about this a little bit. And I think in this talk today, I will be giving kind of a deep dive into this topic. So if you watched already the keynote, it was a very good introduction. And he touched already on this topic. And I'm really happy to share a little bit more details on this, how we did it. With combining two open source projects. I work for a company called Dynatrace. I'm a technology strategist at Dynatrace, and I'm also one of the maintainers and contributors to the Kepen open source project, which is also a CNCF project. And I will be talking about this project a little bit later, and we will be using this as a kind of as the implementation of all the concepts that I will be planning in the first part of the presentation. And let's start with the actual problem that we kind of try to solve today. Because the problem is that our applications, they fail. And it's not only because they have some bugs in it, but there are actually different reasons for this. They might fail because there are some bugs in it, but they also might fail because there are some outages of other services they depend on, or there are some outages in the infrastructure, in the network, on the hosts. So there is a multitude of different reasons why applications can fail. And the whole idea of chaos engineering is actually to test all these different scenarios and to make it more resilient. And we could do this in our production environments. Each time there is an outage, we investigate and we try to make our applications more resilient. But that's actually quite cost expensive and extensive, I would say. Because we don't want to actually do all our testing in production where we have all our end users that are using our websites, our applications, our services. If we do the testing in production, we actually impact their end user experience, and we want happy end users, and we don't want to impact their experience in a bad way. So we should actually try to shift all this chaos, the concepts, everything we can already use with chaos engineering, to shift this left in our pipeline, to put it into a previous stage that, of course, should be similar to production, like hardening phase, staging environment, even a dev environment. So let's really try to use the concept of chaos engineering and all this chaos experience that we might already run sometimes every now and then in production, and really have this as a continuous execution of chaos as part of our CI/CD pipelines. That's the main idea why we want to do this. And by doing so, we can evaluate if our application is already resilient, if it can survive some outages of external services, of infrastructure, network, whatever, and we can keep our production environment safe, up and running, and available for our end users, for them to be happy using our applications and services. So how can we evaluate and improve the resiliency? First, I think that performance and load testing, you kind of need to have these two concepts, or you need to have some stress testing of your applications, but it's not enough to do this. You actually should also do some chaos engineering to really check, really evaluate how long can your application survive. If there is a latency in the network, where is the critical point when your application will break? How long can you survive? If there are some pods that will be destroyed, if there is some CPU saturation on your nodes, how long can you really survive and serve your end users? So you have to establish a process of this kind of continuous experiments and execution of chaos. But not only this, you also have to evaluate and measure the resilience. You have to do those experiments, and then you have to measure the resilience. You have to measure the outcome, the impact of the chaos. And I am a strong believer in the concept of service level objectives. So you should really use service level objectives for defining the quality criteria, defining the quality goals of your microservices or of your applications in general. And then based on the service level objectives, you can do you can make your decisions, and you can start improving based on those results. Like I've just shared here a screenshot of some evaluations. So you can really check, you can experiment with different configurations, with different versions, with different builds, maybe with different chaos already introduced, and you can then really evaluate the resilience of your applications based on service level objectives, because that's really what you want to care about. An objective set on the service, defining the quality of the service, and you have to make sure to reach this objective. Otherwise, this application, this new build, this new container image should not make it to production. That's one of the main reasons. You want to have this as a kind of a quality gate, preventing new versions, new container images of your application. You want to prevent it to move to production if they're not satisfying your quality criteria, your resilience criteria, and this is manifested as SLOs. So how can we now actually use this idea and build it? And I'm also a strong fan, big fan of the whole cloud native ecosystem. So let's build it in the cloud native way. I think that's where we are nowadays, and still the future, or it's still it's still how we should build our applications. So what do we need? We need some kind of chaos engine. We need someone to actually execute the chaos. We don't want to do this by ourselves. We need some kind of orchestrator to trigger the chaos experiments. Think of this as a CD tool where it's actually triggering chaos. And we need some kind of evaluator that is measuring and evaluating the impact of our chaos experiments on our applications. And let's say we have also more requirements on this. We want to have this declarative, scalable, and based on GitOps. Declarative, because that's the cloud native way to do this. Scalable, because also we have usually not only one microservice, but there might be hundreds, thousands of microservices. And based on GitOps, because we want to have one single source of truth where everything is stored, versioned, controlled, and all of this that you might already know what is based on the GitOps approach. So for chaos engineering, at this conference, I think I don't have to explain what chaos engineering is. I took this definition from Wikipedia. The only thing I want to kind of mention here is that we are using Litmus Chaos in this part or in this presentation. I'm a big fan of Litmus Chaos. I'm not one of the maintainers of Litmus Chaos. We've worked with the maintainers of Litmus Chaos together with the Kepen project. It was a very successful collaboration. But you can also use other tools. But I can show you what we've already built together with Litmus Chaos and Kepen. So let's decide on Litmus Chaos for our chaos engineering platform for what we want to build today. So how does it work in Litmus Chaos? Basically, you start with identifying a steady state condition. That's also the idea of chaos engineering. You start to introduce a fault, and you will measure, are the steady state conditions retained again after introducing the fault? If so, you can consider your application as resilient. If not, you have found a weakness in your application. That's the main idea. So how is it built in Litmus Chaos? It's built in a very cloud-native way. You have the chaos operator in your Kubernetes cluster, and you have some custom resource definitions that are picked up by the chaos operator. First is the chaos engine, and the other one that is very interesting for us is the actual chaos experiment. And with this, the chaos operator can kick off, the chaos runner can basically execute the chaos that is described in the experiment file, and after the chaos is finished, it will come up with a chaos result that can be used. So with this, we kind of can check the first box. We found a chaos operator. We found a tool for executing the chaos. We still need the orchestrator, when to execute the chaos, and some kind of evaluation part. And for this, we are using Kepen. Again, you might want to use, or you can use some other things as well. The concepts will remain the same, but in Kepen, you got a couple of features that come in very handy for this part. So first of all, we already have some SLO-based quality gates as a central part of Kepen, and it also comes with all the capabilities you need for continuous delivery. So with this, and with the combination of Kepen and Litmus Chaos, we can build what we wanted to build. So Kepen is also declarative, extensible. It's based on GitOps. We will see this also in the demo. And it's one of its more core use cases is to orchestrate multi-stage delivery based on SLOs and quality gates. So how is it built, and how can we integrate Litmus? I know there is a lot of things on this slide. It's maybe at first sight it's a little bit overwhelming with all these different icons, but the most important part that I want to highlight here is that Kepen is kind of serving as an orchestrator or as a control plane living in your Kubernetes cluster, and different services can be connected. The connection and the communication between these different services is done via cloud events. So we are basically kind of data-driven, and we can make these decisions based on the data. And we do have this integration with Litmus Chaos, for example, for the test automation. We consider chaos tests also as some kind of tests. There are integrations for observability, for example, for Prometheus, for delivery, for example, with Helm, or if you have some Jenkins pipelines, you can also use this, and you use Kepen to orchestrate all your tools. And we can have the different stages where we want to have this orchestration be used for, like a dev stage, staging, hardening, chaos, production, whatever you want. And the cool thing here is that Kepen can communicate with all these other tools and can trigger them, can use the results, and they can trigger other tools based on the results. So let's kind of build this idea of having chaos as part of the pipeline. And I've just prepared a very small shipyard file. That's the environment definition file, but also the sequences that will be executed in this environment of Kepen. And it's basically, I call this staging chaos, this stage, and it comes with a couple of different tasks that have to be executed one after the other. So first, there will be a deployment, there will be some tests, there will be an evaluation, and if the evaluation is good, there will be a release of this new version. And the tests can be some kind of performance tests, functional tests, but just changing the type of the tests, for example, from performance tests to chaos tests, changes basically this part of the, let's say, delivery pipeline without even touching any pipeline code, as you still know from Jenkins, where you have to actually rewrite the whole pipeline. Maybe you have to do it multiple times for multiple microservices. Here, it's just you change the definition file, and with this, you can connect the Litmus integration, and it will execute the tests, the chaos tests, instead of some other tests. Or you can also have two testing tools listening for the same trigger, like chaos tests, and then executing actions. And once they're finished, they will report back to Kepen, and Kepen will then trigger the next task, which in this case is evaluation. So what's done in the evaluation phase? I've already mentioned it's SLO based, but let's just briefly explain the concept of SLIs and SLOs. So SLIs are service level indicators, and we can think of this as a metric. So the indicator is, for example, the error rate. And in Kepen, we map the indicator to an API call, a query, how to retrieve the data. So, for example, in this small indicator file, it's a couple of indicators, and all the Prometheus metrics queries are written here, so that Kepen knows how to query the data for this indicator. And then we can reuse the indicator in our service level objective file. So we can define objectives for all the different indicators. And whenever we want to switch from one tool to the other, or if we want to reuse the objective file, it's absolutely no problem, because there is basically there is no concrete tool definition defined in the objective file. And if the API calls change or whatever, the only file we would actually need to update is the indicator file, which is kind of a library of all the different indicators. And you can still make use of the same SLO files. So we can build our SLO file. It's a kind of a quality gate, our quality evaluation, in a declarative way. And then using this in our Kepen quality gates, either triggered with the CLI or with the API, or being triggered inside the CD workflow. So when triggered, Kepen will reach out to all the different data providers, will query all the data, will evaluate each SLI and SLO, will evaluate it, will give it a score, and will calculate the total score. And then based on the total score, it will allow it to be promoted to the next stage, or it has to be held back or even rolled back, in the current stage. And having this concept, we can really define resiliency, metrics, and quality criteria for our applications. So we will see some parts now in the demo, and I will first briefly explain what we will see, and then we will move into the demo part. So we are using a simple demo application. It's called the Potato Head. It's a CNCF. It's a demo application of the CNCF, and we will deploy it into a chaos stage. We'll be using help charts for this. We'll deploy it into a chaos stage. In this chaos stage, Kepen will trigger tests for us. First, we are going to trigger JMeter tests because we have to simulate some real-world traffic. So we are executing JMeter tests, but at the same time, Kepen is also triggering, with the Litmus integration, will trigger Litmus tests. So two different kinds of tests are triggered. They will be executed. Once they're executed, Kepen will trigger the quality gate. And the quality gate will fetch some metrics from Prometheus, and it will start to evaluate these metrics and come up with a total score. If the total score is good enough, it can be promoted to the next stage. Actually, we evaluate that our application is resilient based on the quality criteria that we defined, or if the score is not good enough, our application is not resilient, and we can do another iteration. We can check what we can change, if we need to change something in the configuration, if we need to change something in the source code. So with this, we can have a continuous evaluation. We can trigger this each time as part of our pipeline. And if you can imagine, if you have larger pipelines, or in Kepen, if you just have the environment definition file, you can include this in all of your pipelines. So the environment basically looks like this. I have a Kubernetes cluster running on Google Kubernetes engine. I have Kepen installed. There is JMeter installed. There is one Prometheus, basically scraping the Potato Head application. I have Litmus installed, and I have added one experiment, which is the pod delete experiment. Actually, we're going to add this experiment as part of the demo. So this is the basic idea. The Potato Head itself is just one endpoint that is interesting for us. It's basically a health check that we will do, and Prometheus is checking if the application is available and if it can serve our valued customers or users. So with this, it's already demo time. Let's jump in the demo, and hopefully the demo gods are with us today. So first of all, let me show you our experiment file. So this is a simple Litmus Chaos experiment file. We are going to use the pod delete experiment. We have a couple of different environment variables that we set, and we're going to add this to Kepen. So Kepen is kind of the basic orchestrator. Kepen can then trigger Litmus with this kind of experiment. And we want to add this to our project Litmus. I called it Litmus. It's just my demo project. I want to add it for a dedicated chaos stage and for a hello service. There's something going on my machine. I'm not sure if you can also hear it, but I will just continue. Hopefully it will stop really soon. So it's the hello service. I will add the resource and I will add it to Kepen. So let's go ahead and add it. Okay, here we go. Now the experiment is added to Kepen. I also do have my SLO file, which is my quality gate. I have added it to Kepen. And there is also now a kind of deployment file that I will have to execute. And let me just quickly go back to the conference part, because it's still doing something. I think there's some alert going on. There is this one. Now I see. I think it was the thumbs up that was doing something here. So let me go back. Okay, here we go. So I'm now starting to, I've added the experiment file, and next is to add to start the deployment of my Potato Head application. So I will do this also with the Kepen CLI, and I will use this description here. It's a cloud event. As said, most of the communication parts of Kepen are cloud events, and I will use this cloud event here to send it to Kepen. So what Kepen is doing, the first part we've seen is deployment, then testing, evaluation, and probably release. So the first part will be the deployment. And let's check in Kepen if the deployment is already going on. And we can see this here in our Kepen's bridge. Let me just reload this. I've done the experiment a couple of times already today, but let's hope for the best for today. So I've just triggered a new deployment. So again, the deployment is triggered. I already see deployment is finished. The next part is that the tests are triggered. And we can see the tests actually in our in an IDE I'm using here. It's called Lens. It's a Kubernetes IDE. And I just want to show you a little bit so I can see there is actually already some chaos going on. There is a pod delete experiment going on. There is already a pod coming up again, a hello service, and there we can see there have been already a couple of things triggered. So what was going on in the background? I was starting the deployment. Kepen triggered Litmus to start the experiments, and also there were some JMeter tests executed. They are not part of this namespace, so we cannot see the JMeter pods that have also been started to execute the traffic generation. But we can see there has been some chaos introduced already. Actually, the job is already completed and will be removed just in a bit. And this was all triggered and orchestrated by Kepen, but actually we want to check what is the outcome. Can we already see something? Is already the evaluation going on? So let us go back to the Kepen's bridge and take a look if we can see something. So we already know the deployment was finished. The tests for the chaos tests have also been finished. Probably it's still waiting for the JMeter tests to be finished. Let us just reload. Usually it takes a minute or two for the JMeter tests to be finished. And those tests, they will also send a finished event to Kepen. So right now I'm here using the latest stable version of Kepen. I'm not using the current alpha version where we could see all the different kinds of events from different sources coming in. I can only see one testing source coming in, and I will see here the JMeter tests coming in because these are the ones that take the longest. We generate traffic for a couple of minutes. It will, once it's finished, it will also stop the chaos experiment if this is running a little bit longer. In my case, chaos has already been finished. It was the fastest. The JMeter tests are still running. Once they're finished, they will send back the result to Kepen. Kepen will reach out to Prometheus, start the evaluation, and come back with a result. So let me just do another reload. Hopefully we do have the results already. And here we go. So the tests have been finished. There was some outreach to Prometheus to query all the data, and what we can see is that the quality gate, and we can see all the quality gate definition here. So our quality gate was to check, and I probably can make this a little bit bigger. Here we go. Our quality gate was to check the success percentage of the probe and also the duration of our probe of Prometheus. And we want the success percentage to be higher than 95%, and we want the duration to be faster than 200 milliseconds. So let's check what was the actual outcome. The success percentage was not high enough. It was only 72%, 73%, and the duration was 400 milliseconds instead of 200 milliseconds. So we did run this configuration with a replica set of 1. And of course, if there is a pod delete experiment running, it will kill the pod. It will take a couple of seconds for the new one to come up. Then we have our readiness and liveness probes. They will also take some time to be executed. Only then Kubernetes is routing the traffic to this. So you can imagine it's causing some downtime if the pod dies and our application cannot serve any traffic. So what we can do here as a first kind of iteration for one attempt to increase the resiliency of our application, we can increase the replica count, let's say from 1 to 3. That's the only thing we are doing, and we send another deployment event to Kepen. We are not doing just a kubectl apply and just change the configuration, because what we want to have is to kick off the whole workflow again. Think of this as another iteration of your configuration of your build artifact. We want to kick off again the whole workflow. So again, we are sending this to Kepen. Let's see what's going on. In Kepen, we should see pretty soon a new configuration change event coming in. It's already coming in, but this time I'm a little bit faster with moving to lens, and we can already see 2 additional pods coming up. This orange color here means they are not yet ready, they are not yet serving any traffic. So still the old version is serving the traffic. It will take around 30 seconds for them to be ready just because of the readiness probe. We allow it to have some kind of slow startup. After 30 seconds, they will receive the traffic. And when the application is finished deploying, then Kepen will go ahead to trigger the tests. And again, there will be JMeter tests and there will be some litmus chaos tests. So we should be able again to see here litmus, the litmus resources coming up with our pod delete experiment, which will go ahead and kill 1 pod. Sometimes this is not reloading, so I'm going ahead and reload this just manually, and we will be able to see what is going on. So we can already see there is a pod delete coming up here, and a new pod is starting up. So it was already killing one of those pods, a new pod is coming up. The interesting part here is the 2 other pods have not been touched. So only 1 pod got removed. The 2 other pods are still up and running. And we kind of can evaluate here if the traffic routing in Kubernetes is done correctly, so that we are not receiving any traffic on the service that is not responding. So all our services are up and running again. The chaos experiment is finished. Litmus itself will clean up the resources here. The pod delete will just, the job is finished and will be removed just in a second from this namespace here. So again, some JMeter tests might still be running. We're still evaluating if the application is serving our traffic. Let's take a look again in the Kepen's bridge, and we should be able to see the new events coming in from, let's say, from JMeter just in a second. I'll just reload this. Probably we can already see it. If not, yeah, we can already see it. So let's take a look here, and then I will show you some other important parts that I really like about this. So what we can see, deployment was finished just a couple of minutes later. The tests have been successfully executed, and now we can see the evaluation of our resilience a little bit bigger. We actually succeeded. So we do have a success percentage of all the probes of 100%, even though we killed the pod. But thanks to our higher replica set of 3, we have kind of high availability of our potato head. So we could serve all the checks from Prometheus with a successful HTTP return code. And also the duration in milliseconds of all of our probes, they are now satisfying, they are below the threshold that we've set. So we now have a way to evaluate and improve the resilience of our applications by combining Kepen as an orchestrator and CD tool and Litmus Chaos as the executor of all those chaos experiments. I've only tried here the chaos, the pod delete experiments, but you can find a lot of different experiments in the Litmus Chaos Hub, and it should just give you an idea how you can build this. And if you want to go for cloud native tooling, it should give you the idea that Kepen and Litmus is kind of a nice combination, and it's really easy to have this to have chaos integrated in your CD pipelines. One part that I also want to show you here is the whole Git approach. Actually, this is the current Git repository that is used behind the scenes of this demo. So for example, in my Litmus experiment just an hour ago, or actually some minutes ago, I added the experiment YAML. This was added to Litmus, to my like my JMeter files, my help charts, my configuration of Prometheus, everything lies in here. Even the SLO configuration that I showed you, it's the exact configuration that I showed you earlier in the Captain's Bridge. So everything is really based on this GitOps approach. So with this, let me go back to my slides just for a quick wrap up. So how can you use this? It's really easy. You can just go ahead and download Kepen from kepen.sh, or with this command, it will just download the CLI, and you can start with using it right from your machine. Then, if you want to add the Litmus service, it's basically just adding the Litmus service as one additional resource. Of course, you also need to install Litmus itself in your Kubernetes cluster, but there you can just follow the Litmus documentation, install it, then you connect Kepen and Litmus, add your experiments, and there you go. We also have this integration up on GitHub if you want to contribute, if you want to take a closer look how it's actually implemented. It was a joint collaboration between the Litmus team and the Kepen team, and we're happy also to see more contributors to the service. So as a quick summary, what have we actually seen today? We've seen how you can define service level objectives to define resilience criteria, but also performance criteria or something else. Just a second, I need to, yeah, all good. But also something else, kind of each objective that can be based on some kind of metric can be defined in the service level objectives. I've also showed how you can integrate these resilience evaluations in your CI or more into the CD parts of the pipelines with Kepen. In Kepen, it was only one change to basically switch from, let's say, performance tests to chaos tests, and off you go with the integration that we already built for the community for you to use. And we've seen how to really enable the continuous evaluation based on the SLO files. So with this, thanks a lot. I am happy to answer some questions. Also, if you are interested in either the Litmus Chaos project or Kepen, I'm more the expert on the Kepen part, but I'm sure at this conference you're in the best hands also to join the Litmus community. If you're interested in the Kepen community, we have our own community site. We have everything basically on kepen.sh. You will find the documentation. It's, as said, an open source project governed by the CNCF. We're happy to see you in one of our developer meetings or just as a visitor on the Kepen website, and hopefully as a new Kepen user really soon. So thanks a lot, and I'm looking forward to some questions. Just
Thanks,
switching
Jürgen.
back.
Yep. Thanks, Jürgen. That was really great session. Like, being from a Litmus team, I also learned a lot today from your session as well. Like, I have also been working on pipelines, so it was really great, like how we can use now chaos inside the pipelines, and how you can do a continuous evaluation based on SLOs. It was really great to see. Thanks, man.
Let me just open the window real quick here because there's my cat outside. Sorry for this.
Okay. Oh, okay.
Some cat content is always good during conferences.
Yeah. We must be having some cat lovers too. Yeah. Okay. Let me see if we can take some questions as well. So there is one question from Cheyenne. So does Kepen help with monitoring production for SLOs and taking remedial action based on the same?
Yes, very good question. So I've only showed how to kind of bring the concept of chaos engineering into the pipeline before production. But one big part of Kepen is to using these SLOs either for configuring monitoring systems that can start their alerting based on these SLOs, and based on the alerts Kepen can in turn trigger remediation actions. So that's actually a very interesting use case that we already kind of discussed also with the Litmus team, for example, to kind of have chaos engineering as tests for self-healing instructions for applications. And that can be done. Maybe next year at Chaos Carnival we can showcase this already. We can showcase this earlier, but it would also make a nice contribution for the next edition of the Chaos Carnival.
Sure. Why not? Okay. There is one more question from Oliver. So I think that should be Kepen. Can Kepen be used with Flux CD?
Also, very good question. Right now, we don't have the integration with Flux CD. There are a couple of tools that are very high on our list. There is Flux CD, there is Argo Workflows that we want to either start or improve our integrations. So with Flux CD, we have not yet started, but if there is high interest, please just comment on the issues in our GitHub repository to kind of give more importance to those, and we can make sure that we are kind of prioritizing them in the right order so that we can get started more sooner than later on integration with Flux CD.
Okay, great. One more question. So this is from Prithvi. So what's next for Kepen in its chaos engineering story? So, like, what are the immediate requirements Kepen believe Litmus caters to be in taking towards the roadmap?
I think what's really what's now really interesting is using chaos really as a trigger for auto remediation and self-healing scenarios. I think in the same idea that you usually have some kind of tests to evaluate performance, we can use chaos to evaluate some kind of self-healing and remediation actions, such as scaling, such as some restarts, some reconfigurations, talking of feature flags, all these kind of things we can think of. We already have the part of the remediations, but I think the next part is to kind of combine them. And for the particular integration of Litmus and Kepen, what's also on our roadmap is to use the Litmus chaos results as a source for Kepen to build their evaluation on. In the demo, I've shown how we are using Prometheus metrics to base our decision on. For example, if the probe is successful, if the probe is fast enough. But we also want to use results directly from Litmus to base our decisions on, and not going via another third party in terms of Prometheus, for example, but directly using this as they are provided as custom resources anyway.
Okay, that's good. They are liking your talk. They are saying it free. So, there is one more question. So, so what are the typical actions or procedures that accompany a failed quality gate or SLO test in CD pipeline?
Pardon, can you repeat it again?
Yeah. So, what are the typical actions or procedures that accompany a failed quality gate or SLO test in CD pipeline?
So the typical procedure to integrate it, right?
The typical actions that accompany a failed quality gate or SLO test in a CD pipeline. So I think it's towards integrate. I think, yeah.
Okay. So for the typical actions, when you start with integrating SLOs in quality gates, they are basically starting with using some relative thresholds to use to kind of find out what are the best thresholds for the application. Sometimes if you have hundreds of microservices, You do not know which microservice is responding the fastest, which microservice takes a little bit longer. So you start with kind of finding the correct thresholds, and you can start with just defining some relative thresholds to allow some variety, allow to move between some, let's say, the response time has to stay within some boundaries for the next couple of deployments and the next couple of runs. And once you find out the exact thresholds, then you can basically define an exact threshold, and then you can get started. And then the quality gate will fail or will open up and will move into production. This is one of the parts, but it's a very interesting question and really defines or really is very changes between organizations a lot. What are the right starts for setting SLOs in a quality gates? It's not very easy to answer because absolute thresholds are very very different between all the organizations.
Yeah.
Hopefully that answers the question.
Yeah. Okay. So yeah, I think that was a very great session as well as a good Q&A. We found very good questions there. And yeah, we also found that Jürgen is a cat lover as well.
Yeah, so sorry for the interruption, but I had to.
Oh, no, that's good. Okay, yeah. Okay, yeah, then I think we can close in. That was really a great session. Everyone, if you have any more questions post presentation, you can also take your questions to Slack channels. We will be there to answer your questions. So, yeah. Okay.